So all we're doing is we're just seeing if this gives us 0. And if it gives us 0, it's a factor. If it doesn't give us 0, it's not a factor. It's that simple. So I'm going to tell you, because we've already done this problem, I'm not going to make you waste your time typing something in, that this is going to give you 0. You do get 0 on this problem, so that tells us that what? It's a factor. It also means that it crosses the x-axis where? No. At positive 8. It tells us 8 is an x-intercept. Because zeros and x-intercepts are the same thing. So we know this graph's going to cross the x-axis at 8. We could do synthetic division now to find the rest of our factors. So if I were to do synthetic division on this problem, I have 8. And then inside my box, what do I have? You skip something. 1. Okay, so synthetic division review, because it's been a while since we did this. I'm going to bring down the 1, and then what do I do? Yes, 8 times 1 is 8. Negative 22 and 8 is negative 14. And 8 times negative 14 is negative 112. And 157 is 45. And then 8 times 45 is, and negative 360 and 360 is 0. So then labeling everything, starting from the right end, wrong direction, sorry. It's remainder and then, okay. So I could say that x squared minus 14x plus 45, not 55, plus 45 times x minus 8 is going to give me, if I would actually multiply that out, it would give me my original function of x to the third minus 22x plus 157 minus 360. Can I factor this second one even further? The first one, I'm sorry. Can I factor x squared minus 14x? It'd be x minus 9 and x minus 5 and then x minus 8. So now that I have these three factors, could I turn around now and graph this? Yes. Because I know what the generic shape is. I know what my x-intercepts are. That's what we spent all of 6.2 doing. So I could turn around and I could graph this if I needed to. Okay, so look at page 413 on your, on 8.1. Okay, so when I have a problem like this first one here, at the very top of the page, it asks us to identify the zeros of this polynomial. How would I identify the zeros of f of x equals x plus 2 times x minus 1 times x plus 3? I set it equal to 0 and solve, and what ends up happening to each of my signs? They get flipped. So my x-intercepts or my zeros would be 2, 1, and negative 3. If I were to give you a problem, this problem is not in there anywhere, but if I were to give you a problem and I were to tell you that your zeros of your function were negative 4, 12, 2, and negative 3, could you then turn around and write your function? Yeah. Okay, what would your function be?
X plus 4, x minus 12, x minus 2, x plus 3.
Okay. And what would happen if I were to plug in, let's say I plugged in 12 for x. What would I get out as my answer?
0.
I would get 0 because we know that 12 is an x-intercept. We know that x minus 12 is a factor, so therefore plugging in 12 should give me 0. So there's this theorem called the rational zero theorem, or the rational root theorem, is what I learned way back in the day. And then the state of Texas decided that we don't need to use the word roots anymore, which is really annoying, but whatever. There's a big jumbo mumbo of stuff. If p of x is a polynomial function with integer coefficients and m divided by n is a 0 of p of x, implying that p of m divided by n equals 0, then m is a factor of the constant term of p of x and n is a factor of the leading coefficients of p of x. Okay, find the zeros of this function without graphing it. Well, your first thought is, okay, cool, I need to factor. Because if I can factor it, then I can find all my factors. And if we have all of our factors, then we can find all of our zeros, or our roots, or our x-intercepts, because they're related. That's kind of what we did in 6.2, is we learned the relationship between our factors and our x-intercepts, or our zeros. The problem is this doesn't factor. And they didn't give us a problem like in 7.4 when we did long division or synthetic division. They gave us a factor and said, hey, verify that this one is a factor, isn't a factor, and then find all the other ones from that. They didn't give us that either. So there's a third way that we can use that will give us all of those numbers. And it's called the rational zero theorem. And what the rational zero theorem says, essentially, summing it up into words that actually make sense and not just a bunch of random things, is that you can make a list of all of your possible zeros of your function. The rational zero theorem says that you can make a list of all of your rational zeros, all of your possible zeros, by knowing two things. And those two things are factors of the constant term divided by the factors of the coefficient. Factors of the leading coefficient. Sorry, I should have written that. Factors of the leading coefficient. Okay. So, talk to me about my factors of negative 20. What are the things that divide evenly into negative 20? Okay, positive and negative 10, correct? Okay. What else? Positive and negative 2. What else? 4, 5, 20. Okay. All right. So the 20 is my constant. How do we know which one our constant is, by the way, in the problem? The one without x. Always the one without x is our constant. Okay, what's my leading coefficient in this problem here? 1. So what are the factors of 1? Just 1, positive and negative 1. So now I'm going to make this table. You'll be like, why are you making this table? Just trust me. Trust me that I know what I'm doing. And in a second, you're going to be like, whoa, this is amazing. Promise it's going to happen. Well, some of you. Others of you don't care, but it's good. All right, so now let's actually divide them. So what if I were to divide positive negative 10 by positive negative 1? What's 10 divided by 1? 10. So I have 10 and negative 10, because depending on how my signs work there. Okay, what about if I were to divide positive and negative 2 by positive and negative 1? What would I end up with? 2 and negative 2. Okay, same thing with 4. If I were to divide that by positive negative 1, I would end up with positive 4 and negative 4. Okay, what about 5? Positive and negative 5. Okay, what's my next one? 20. Okay. And then the last one was, okay. So here's what I want you to do now. We are going to, well, actually I'm going to ask you. So if I know that some of these are possible zeros, because I'm telling you they are, some of these possibly are zeros of this function, how can I figure out which ones are actually zeros of the function? I plug them in. And what should I get?
0.
And if I don't get 0, what does that tell me? It's not a 0. So that's what we have to do now is we have to plug them in. Okay, for positive 10, when that got plugged in, what did you get out? For positive 10, when that got plugged in, 990. Okay, for negative 10, when that got plugged in, what'd you get?
Negative 199,830.
We'll come back to negative 10. So for positive 2, it's what? Negative 42. What about for negative 2? 18? Okay. For positive 4, what'd you guys get when y'all plugged that in? Okay, what about for negative 4? 20 what? Okay. What about 5? Negative 5? Okay. What'd you guys get for... You, okay. For 20, what'd y'all come up with? What'd you get for 20 when you... 840? Okay, what about negative 20? Okay, what about 1? What about negative 1? You got 0 for which one?
Oh, okay, yeah.
Negative 1, you got 0. Okay, that makes sense.
Negative 10 is negative 630. What? I got negative 850.
I think it's...
630.
Yeah, that's negative 630 for that one. Okay. All right, so... Okay, so look at this list. Of my 12... 2, 4, 6, yeah. Okay, of my 12 possible zeros, how many of them actually are zeros? 3. So I know that 4 is a 0, I know that negative 5 is a 0, and I know that negative 1 is a 0. So if I know my zeros, what else do I know?
Your x-intercept.
Your x-intercepts. You also know your factors. What's my first factor?
X plus 4.
X minus 4. What's the next one?
X plus 5.
And what's the last one?
X plus 1.
That is my factorization of that problem. So when we do problem B on the next page, again, we're doing our factors of our constant divided by the factors of our leading coefficient. Okay, so what is my constant in this problem? In problem B on page, whatever page we're on. What's the factors of what is our constant, sorry? 24. Okay. So talk to me about all the things that divide into 24.
6 and 4.
Okay, I heard 6 and 4, so positive, negative 6, positive, negative 4, 8 and 3, 12 and 2,
24 and 1.
and 1 and 24. Okay. Okay, so that's my constant term.
After 3,
An 8. Sorry, it's an 8. So that was my factors of my constant, were all those numbers. Okay, then I have to find my factors of my leading coefficient. What's my leading coefficient? 1.
It is. Where's the... Oh, right there.
It's not always 1. What do we say? What do I mean when I say the leading coefficient?
The number in front of the first is.
The number at the very, very front. So whatever the coefficient of x to the 4th is. Okay. So if I actually do some math here, and this is, okay, if I do the math, and let's make this long table. Okay, so if I divide, 6 divided by 1 is 6, or negative 6, so 6, negative 6. Okay, what about 4 divided by 1? 4, so 4 and negative 4. Okay, what's going to be my next pair of numbers in this table?
So you're dividing it by the...
I'm dividing it by the 1. I'm actually doing all the division. I'm doing 6 divided by 1. I'm doing 4 divided by 1. And then 3 divided by 1.
So you would be 6 divided by 2.
Yes, if there was a 2 down here, then yes, we would do that. And we're going to do one like that in a little bit. Okay? Okay, how do I know it's a 1? So the 1 has to do with the factors of the leading coefficient. So leading coefficient is the very first term in our problem, which is 1. And what are the factors of 1? 1 and negative 1. Because you can divide 1 by negative 1.
So those are all constants, basically, and you're dividing all of them by the leading coefficient.
Yes, that's what I'm doing. I'm dividing the factors of the constant, the factors of 24, by the factors of 1, which is just 1.
You start with one constant, and then you make a list of...
Yes, you start with the constant, make that list, start with the coefficient, then do the coefficient, make that list, and now I'm actually dividing them. So 6, negative 6, 4, negative 4, 3, negative 3. What's the next one? 8, negative 8. 2, negative 2, then... Okay. What was the next one? Okay, 1, negative 1, and So I have a list of 16 possible zeros. So I've narrowed down my list of zeros to 16 numbers. So now that I know my possible ones, what do I do to figure out which ones actually work? I have to work them all out. Okay, 24 and negative 24. What did you get for positive 24? 73,000? 273,000. Okay, what did you get for negative 24? Something. Okay, just a big number, right? Not zero, essentially. Okay, what did y'all get for 1?
36.
What did you get for negative 1?
0.
Okay, what did y'all get for 12?
13,104.
13,104. What did you get for negative 12?
20,400.
Okay, what did y'all get for 2?
24.
What did you get for negative 2?
0.
Okay, what did y'all get for 8?
1,800.
What did you get for negative 8?
5,544.
Okay, what did you get for 3?
I'll do it because I could.
I know
What'd you
negative
get?
3 is 84. 0.
3 is 0 and negative 3 is what?
84.
84. Okay, what was positive 4? Because I skipped that one. 0? Okay, that makes sense. So how many zeros are there of this function?
4.
Do you know how you can tell how many zeros there's going to be before you do any work?
How many of the X?
How many x's?
How many independent thingies or whatever?
Right. You got the x's.
If I know my 4 zeros, okay, what's my first factor?
X minus 4.
Okay, what's my next factor?
Minus 3.
Okay, what's my next factor?
Plus 2.
And my last factor? Okay.